welcome to the Ballast Water Management panel of this 2021 GREEN4SEA virtual forum. In this panel, we'll be talking about the ballast water management. The convention entered into force recently, and from 28 September of 2020, ballast water treatment systems are required to meet the Ballast Water Management Convention type approval requirements by the IMO, instead of the revised G8 guidelines, as well as the US Coast Guard type approval regulations. So until today, US Coast Guard has granted approximately 40 type approvals in total. And what we would like to discuss beyond this, let's say, the revised G8 guidelines and the approval process and where we stand with the US Coast Guard, we would like to discuss what's next on the regulatory agenda. We would like to hear updates from the makers, and we would also like to hear from other players in the market. What are the key operational challenges in installing ballast water treatment systems, any sort of issues with the training, with lessons to be learned, any feedback to the market, and so on and so forth. And we would also like to discuss about best practices. Now, in order to have this discussion, we have gathered a panel of experts. Let me introduce them to you. We have Effie Tsolaki. Effie is the Chief Scientific Officer of ERMA First ESG Engineering Solutions. Dimitris Tsoulos. Dimitris is the Regional Sales Manager for EMEA for the Nora Marine Technologies. Panos Smyroglou, who is the Director of Business Development for Ecochlor. The three first members of the panel are representing makers. We have Jad Mawad. Jad is the Chief Executive Officer of Mawad Consulting, a well-known, let's say, figure and very well-respected figure in the market with respect to ballast water management, the convention, the consultants required, and so on and so forth. And last but not least, we have George Kriezis. George is the Technical Manager of Neptune Line Shipping and Managing Enterprises, representing the owners / operators / managers on this panel. So, meaning he'll have his say on more practical terms. So I would like to welcome you all. And as we have the introduction as the first order of business out of the agenda, I would like to ask you to start with your presentations. We will have a set of presentations. And I would like to start with Effie.
So good morning to all. Good afternoon and good evening. Here is the presentation of the commissioning testing of ballast water treatment system experience. We will have the chance to present the regulatory agenda on the legislation trends on the circulars. I will have the chance also to present you the ERMA First experience and shed some light on the guidance release, the commissioning testing date and the recommendation. And last, I can present you what is the latest industry guidance. So what about the IMO commissioning roadmap, where we stand? So there are some flags that are countries which are requesting compliance testing during the commissioning. And these are Singapore, Australia, Cyprus, Croatia, Tuvalu, Canada, Greece, France, and India, while there are others like Bahamas, Liberia, Panama, and Malta that are recommended the commissioning sampling during the first installation. There are also some from the European Union, some recommendation, and the EU announced the adoption of the compliance testing and commissioning of all of its member flags from October 21 and onwards. From the class perspectives, there are some classes like LR and DNV that are recommended commissioning sampling for their class vessels, while there are others like ABS, LR, and DNV that are having and set up a sampling provider approval scheme. What we need to keep here is that the IMO commissioning test is not APA VGP. So for the US, we do have different regimes like EPA and VGP and 46 CFR. So what about where we stand in the IMO commissioning testing roadmap concerning the circulars? Now we do have two in place, and these are the Circular 70 that was released back in November 2018, and the revision 1 that was released in December 2020. For the first one, an ambient water uptake characterization was required. The samples should be collected during the corresponding ballast water discharge after the full treatment has been applied. And of course, the samples should be taken in accordance with the guidelines of ballast water sampling from G2. There was, for a representative sample, the sample should be analyzed for all size classes. That includes the D2 and the indicative methods listed in Table 3 of Circular 42 Revision 1. There are also applicable self-monitoring parameters of ballast water management system that should be assessed and taken into account the SDLs, and the correct operation of the all sessions and related equipment should be confirmed. So in December 2020, we had the revision 1, and that means that the local water should be used for testing regardless of the level of the challenge it poses to the BWMS. We do have an optional ballast water, ambient water uptake characterization. The representative sample follows the circular 17 with the addition that the total volume should be at least 1 cubic meter. And if a smaller volume is validated to ensure a representative sample, it may be used. The main difference is that for representative samples, 2 size classes should be analyzed, and this are mainly more than 50 and 10 to 50. And for the assessment of SDL is the same. This latest revision of the Circular 70 will be entering into force in 1st June 2022, and these are the resolution MEPC 325 of 75. So allow me to share some ERMA first experience. We do have more than 1,200 units successfully commissioned until the April 2021. And this is a map where you can see the spread of ERMA first system installed on board vessels worldwide. So back in 2018, we started receiving requests from ship owners while they do the VGP sampling and analysis. So we launched a guidance for ship owners in order to provide them clear instructions to them and to the operators and the crew in order what they should follow prior to any sampling in order to avoid any non-compliant sampling. So it is good to be proactive. So this guidance in 2020, it was actually enriched with the IMO references and sections. And allow me to provide you some general recommendations to the ship owner. So it is good to go and contact first your flag or the RO of the vessel for taking the approval on the procedure and the circular that is acceptable. Secondly, it is good to update your training program to include latest circulars related to the commissioning. So the designated officer should be familiar with the procedures, and the resources should be added to the ballast water management plan. So last but not least, should liaise with the vessel's flag and RO in order to request the latest instructions and guidance regarding commissioning and issuance of the ballast water management certificate. So just a brief instructions on sampling steps of ballasting. So they say avoid the contamination on the ballast tank. Samples should be taken from a proper tank. The system, make sure that the system is functioning. The filter screens are in good conditions, check the status of the vessel valves and the ballast water piping, and correlate the ballast water record book and data retrieval of manufacturer. Crew should always follow the OMSM. For the deballasting, make sure that there is no valve open during the deballasting. The sample is taken from the proper G2 sampling port and the neutralizing agent is available. Also, the crew should follow the OMSM instructions and mitigate any scenario where the MNC is more than 0.1 milligrams per liter. So allow me to present some IMO commissioning sampling data that we have. So until now, we do have and present 35 vessels that they had sampling via an independent service provider scheme, and this is the distribution of them between the flags and the classes. And until recently, there are some flags that are requiring commissioning sampling following the Circular 70 Revision 1. So before June 2022. So in order to conclude how to handle compliance in general, so it is good to first sample an independent arrange a sample by an independent and certified body, and it is good to combine IMO and VGP analysis. Secondly, it is good to have to be proactive and have on board a portable testing kit for indicative sampling. And the third, it is to use the training services. So don't wait until the last meeting during the commissioning to train your crew, but use all the tools that manufacturer has, like system simulator, hands-on training, e-platform, and training centers. So for the latest industry guidance, as BIMA, the Ballast Water Manufacturers Association, we released in December 2020 a guidance to support the practical implementation. And this is clear that for a successful commissioning, a stakeholder collaboration is required by all parties of class society, shipyard, vessel owner and crew maker, installer, engineering firm. So thank you for your attention.
Thank you very much, Effie. Let's hear from Panos.
Thank you for having us today in the panel. My name is Panos Smyroglou from Ecochlor, the Director of Business Development. I'm excited to, after the public announcement that we did earlier on this month, to give you some highlights of our new version of our system, keeping the same core technology, but eliminating the filters. This is the Eco 1. Chlorine dioxide treatment technology has been used by us for many years after land-based installations and so on for different applications. And the fact of the matter is that chlorine dioxide disinfection is effective regardless of turbidity, salinity, and temperature. This is why filtration is, as a matter of fact, not necessary in order to remove sediments prior to treatment with chlorine dioxide. I'll stay a little bit longer on this slide and I'll be faster, apostolate, on the next ones. Here I have a brief comparison, basically, of chlorine dioxide versus sodium hypochlorite or chlorine. That is produced by electrochlorination systems, and I'm doing this especially to highlight what goes on with the two different technologies when the filter is removed. So how about the chlorine dioxide dose after removing the filtration? Everybody will ask this. Well, the chlorine dioxide primarily reacts with living organisms. You can see on the graph next to you on the right-hand side, column A. So it's available, the volume A, for living organisms, unlike sodium hypochlorite that gets consumed by non-living organisms. You see the red portion of chlorine on the same graph. So what does this mean? Well, and why it is happening? Well, the sodium hypochlorite reacts, I repeat, with both living organisms and non-living organisms. Because of this, such technologies need increased dosage especially when filters are removed. And this is the prime reason that an electrochlorination system, if I may say, would not be a good option for a filterless application. Long term, the high dosage in such cases could potentially damage the tank coatings. Contrary, chlorine dioxide has a very limited reaction with organic compounds, so the required dose of chlorine chlorine dioxide in dirty, let's say, water when there is no filtration is significantly less and does not require neutralization at discharge or issues with any issues with tank coating. And this is the main new system. A lot of things are the same, like our two chemical tanks, which we mix the two chemicals and we produce chlorine dioxide, and then we diffuse this into the, let me get a laser pointer, by the way, and we diffuse this into the slipstream, 0.25% of the flow, and we put it back into the flow. What is missing is the filtration step, which had been here. So it's a single step process of disinfection, even simpler, even more reliable. All the components 1 to 11 remain the same. The number 12 is the only new component, the motive water duplex strainer, since we remove the filters. The dosage here, 4.6 ppm, very low, safe for the coatings. Salinity limitation above 1 PSU for fresh water, but this applies only for Eco 1, whereas Eco 1 hybrid, which you will see on the next page, has no salinity limitations. Water temperature, not limitation. Holding time, the same as before, 24 hours. And here on the right, you see the different models for different pumping rates. The Eco 1 hybrid is for cases where the crew needs to have the ability to have a two-step process. Then basically the system as in the past with a filter when needed, and one single step process for other times. Again, the only added part is the strainer here. Benefits: less equipment installation cost with the same reliability, easier operation for the crew, lower maintenance needs, decreased power requirements. For the hybrid, all of the above, and the crew can exercise the option of the two-step, as I said. Both options, Eco 1 and Eco 1 hybrid, are available for vessels that already have our ballast water treatment system with filters installed and would like to upgrade their system. Approvals for the new system. To start with, we have finished our lab testing in March. Type approval for the IMO is expected in the third quarter of this year, as we are completing, as we speak now, our shipboard testing on Aframax and VL of marine tankers. The type approval certificate for the US Coast Guard, well, the next 1 quarter after that, fourth quarter this year. Classification Society's type approvals will be first quarter 2022, same with the flags. Thank you very much, Apostole, and everybody.
Thank you, Panos, very much. Let's hear from Dmitry.
So thank you, Apostolos. Thank you, GREEN4SEA. Firstly, let me introduce us. So I'm Dimitris Tsoulos, responsible for the product systems and services that the Nora furnish in the marine market within the EMEA region, and I'm located in Athens, in Greece. The Nora is a global leading designer, manufacturer, and supplier of electrodes, coatings, and complete electrochemical solutions to serve diversified markets. And exactly this experience has been utilized to develop the BWMS ballast water management system that is based on the principles of filtration and slipstream electrochlorination. So as we're still navigating into the experience building phase, I anticipate that the topics that we have been invited to address today are on high interest for the owners and operators, but also claim responsibility for us, the makers, in order to meet a challenging way forward. I trust that EFI have elaborated very well on regulatory compliance topics, and at this limited time, I decided to concentrate on the maker's view and specifically address the key operational challenges with a view to the way forward. Said that, our view is that the key operational challenges are balancing between the pillars of system performance and contingency planning. Trying to list down the voice of the stakeholders on system performance, certainly we will need to concentrate and cope with the following topics. So primarily, the selected technology. Our experience so far is that now more and more owners and operators do have a clear view on which technology fits for purpose in their vessel design. This is mainly driven from the experience that they have been built, and this actually challenges the existing installations where systems have been installed in early phases and proven to be incompatible with the vessel operational needs. Driven from the technology, reliable filtration is a key element for regulatory compliance and, of course, effectiveness on operations. However, filter performance has proven to be a headache for the industry. And for this reason, we have seen recently more and more the decision makers to be heavily engaged on the filter details and ultimately to the final selection. As we are coming from the electrochlorination world, effective filtration ensure optimal disinfection by sodium hypochlorite produced by the technology of electrolysis, meaning power consumption. All right, I don't want to expand further on the planning around this topic, but just to highlight that under the initiative of emission control and in view of emission trading system implementation, power consumption is proven to be a challenging operational aspect and a decision driver in many cases. Moving forward, there has been a lot of discussion on the analyzers. All right, the TRO analyzers that have been installed on ballast water applications are based on the DPD method, and those analyzers are widely used in the drinking water industry. They are known to operate reliably in that environment, but the working conditions are very different to a seaboard application. Apart from heat, vibration, humidity, and salinity that technically are challenging, the way a system is operated is fundamentally different. Sensors in these land-based applications are continuously operated and maintained by personnel specifically trained to take care of analytical instrumentation. In the ballast water application, the TRO sensors are operated only every few weeks by the ship's crew, for whom this is just an additional task. Of course, recently, less complex amperometric TRO sensors have been developed, but they are still very much dependent on water quality and are hence not well suited for the changing waters ships mostly operate in. A reliable alternative are ORP analyzers who promote simplicity on installation and maintenance, and of course, much better operational record. In the slide, I have also listed system design limitations. And before all, I acknowledge the importance of full transparency on the system design limitation as included in the IMO certificates under the code. However, the transparency on SDLs shall not be used for a blind evaluation of a system, but shall provide an excellent platform to evaluate operational conditions of the system and ultimately plan the investment and way forward. Some questions. What is the rated treatment capacity on different types of water? What if the temperature is below the approved? How much saline water shall I store when ballasting in fresh water? And if we want to expand this discussion, what is the impact to my equipment when operating in threshold conditions? How do I safeguard quality and minimize the risk of failure in the next operation? Said that, this brings me very well to the next pillar, that is contingency planning. Understanding how the system works is very important. This exactly makes training extremely important. Makers should have the right training tools to assist the crews, but not only limited to system operation and maintenance training. Training for compliance is also very important. Crews must be aware about the regulatory and the port state control requirements. Certificates, reports, logs, everything around the system shall be easily and readily available, and the crews must be trained on that as well. Ship owners should review the scope of supply and together with the maker identify vulnerable parts that they will need spares for. Makers should have designed the system with as much as possible commonly used marine approved parts and have a network of spare suppliers strategically located around the world to shorten delivery times. And predictive maintenance, also known as condition-based maintenance, is a very important tool for contingency planning. Predictive maintenance is maintenance that monitors the performance and condition of equipment during normal operation to reduce the likelihood of failures. We in the Nora, this service is provided as standard. The operational logs of the system analyzed by our experts, and then a technical report is submitted to the operators for evaluation, enhancing preventive maintenance support. And speaking about preventive maintenance, yes, we all agree that preventive maintenance is important, either by the crew or by the makers. But this sometimes requires special equipment that may not be available on board, and respective planning shall be taken into consideration. At last, ship owners must rely on their own resources and internal communication during changeovers. Owners should study operational performances of their ballast water management systems, share experiences among their fleet, and find ways to improve their performance, always in consultations with the maker. I feel that we can speak on this slide for hours, but with that, I would like to thank you for your attention, and I'm looking forward to your questions.
Okay, thank you very much, Dmitry. Jad.
Good morning, all, and thank you for inviting me to speak about the topic of ballast water management. I'll be talking a little bit about more makers in the market than the three we have just seen. How many are there? What are the options in the market? A little bit on the retrofit situation, how we see that. I'm going to talk more about some of the technical challenges that people are always asking me about. And so I'm listing them in some of my presentations, and I'm going to do that here, and a few recommendations at the end. To start with, I want to give an overview of the available systems with the approvals. Those ones, what I call viable ballast water management systems, which means that are systems with approvals, but that you can actually buy, because there are a large number of systems that you simply cannot get hold of. In total, we count around 43 of those systems. 36 of them are USCG approved, some 29 of them are IMO, and 28 are both. And then we divide them into UV-based, electrolysis-based, and which are a large number of the market, the majority of the market. And then the other systems, for example, like the Ecochlor system that was just presented. In the market, we see that if you are a ship owner now and you want to go out and buy a system, you have a very small ship, you would probably go for a UV-based ballast water management system, and you need it to be approved, and you're trading with the US. In practice, you only have actually 12 systems to choose from. And if we look at more and more details, you can actually boil down your options to 3 or 4 systems very easily. So as a ship owner, doing a background check and checking what your ship needs and what you want in order to keep your ship trading as you expect is really not that hard. And you can always end up with 3 or 4 systems that you can actually choose from, that we always recommend when you're doing a retrofit. A little bit on the retrofit market, we see that everybody talks about this peak coming up in 2022, and we talked about it in this forum 3-4 years ago, pre-Corona time. This peak that we expect in 2022 is really not, it's based on the certification dates of class societies. Ships do not retrofit ballast systems based on the renewal dates of certificates. They retrofit them during dry docks. And so you dry dock your ship in 2021, even though your IOPP renewal date is not during the same time, you will retrofit your system. So if we look at the number of ships, and those are based on a correlation of all class societies numbers, approximate, of course, everything is approximate. We expect always around 70 to 80% of those ships to be retrofitted in China. So I've put all those numbers above each other. In reality, the curve will most probably look like this. We will see more retrofits in 2021, 22, 23, and 24 will be more equally divided than what we have seen here, which is like this curve. The reason for this is that this will be spread to the dry dock schedule of the ships. Now, do we have capacity to do all these dry docks? Yes. We have been dry docking ships for the last century or so, and we will always have capacity to dry dock ships. The only problem we would see, of course, is if the retrofit of both scrubbers and ballast water management systems will delay and prolong those dry docks. If they all do that, then capacity becomes a problem. If they keep to the normal dry dock, time of the ship, and we manage to retrofit the system during that period, then this will not be a problem. We'd rather put the problem on availability of supervision, spare parts, and small equipment, etc., rather than availability of shipyards. This is how it looks like now. This does not take into account the effect of the coronavirus and the delays we have seen, a few months here and there. We have to keep in mind that China has been having business as usual for the last year or so. So those corona effect is not very obvious always with those numbers. I wanted to throw out this standard chart of a retrofit that I always recommend, and I always put on my slides so that people can keep in mind that if you follow those steps, you will most likely end up with a good retrofit. It's you do your homework, you end up with 2 or 3 systems. You send I always stress and recommend sending a marine engineer to do the scanning and not a 3D scanner that pretends to be a marine engineer, but the other way around. A good engineer with a camera is much better than a cameraman who wants to be an engineer. Do the survey, put the system, do in 3D, do the piping, structural, electrical, pressure drop, very important. We are seeing a lot of problems with pressure drop on ships. I also looking at sending somebody to do the supervision during the installation is very important. Commissioning that Effie talked about earlier today, and also the operation that I'm going to talk about now. Now, we have a large number of systems installed. Now we have probably 10, 15,000 systems, even probably higher than that. So we are starting to see how those systems are working on ships. For UV-based systems, it's always the water quality that has been challenging, fouling on lamps and so on. We see that vibration on ships, especially if you are not doing a proper installation on support for pipes and so on, is breaking those lamps. Those have been the major issues. I always recommend that for larger units you use, we see now a trend with large ships installing UV-based systems. For some reason, so ship owners are choosing that. I have seen that more and more than in the past. Then I recommend putting a variable frequency drive on those large pumps to control the flow rather than controlling it with a valve, because that's creating a large forces on the pipes and breaking them. Spare parts, adequate training, same for all equipment. That's important to keep in mind. For EC-based, again and again, it's the TRO meters that we are seeing that is challenging. Those, especially the colorimetric ones, the ones that take samples and they send light to see how much TRO you have, are very accurate, but they don't work on ships. We barely see them work on ships. They're always broken. They always have a problem. There are alternatives, ORP alternatives. I think the Nora system uses an ORP alternative, and I also know that there are halogen-based, for example, the halogen TRO meter has had a lot of good feedback, and amperometric-based TRO meters that are more robust and giving good readings that we should start consider putting on ships that are more reliable. Besides that, of course, low salinity, low temperature, like we discussed earlier today, this is always a challenge. Maintenance and calibration of sensors is very important. Hydrogen sensors calibration, it can be a nightmare for normal people. So that can require special tools to do that, and can be a challenge. Cleaning of filters, important. Keeping your equipment up and running is vital, like any other equipment you have on the ships. And what we just discussed, you can do as much as you want the remote service and operation and support, but at the end of the day, those equipment are so-called specialized equipment, so you will always need somebody somewhere to go on board and do some checks, do some commissioning, do some repairs. Even though the crew can do most of it, but there is still, that's an important part of of the issues we see. At the end, some recommendations. Start your retrofit early. I've been saying this for the last 2 decades, probably I've been doing this. 6 to 9 months in advance. Boil your options down to ballast water management systems that fit your ship. There are many tools. You can use people, you can use your own judgment, but don't go with open mind. Just go with 2 or 3. That makes life much easier. And if you checked actually, and as I showed in my previous slide, you can easily boil down to a few options. Ship survey is more important than the 3D scanning. I always recommend surveying the ship, knowing exactly what you want the equipment to do, rather than just take the pictures. Sending a marine engineer, my experience is it makes a big difference. Arrange a local supervision during retrofit. Those 2 things have shown to especially the supervision, have shown to make a difference between the success and failure of the retrofit. Especially if it's a shipyard that is not well versed in retrofitting equipment like ballast water management systems, and it's good to have somebody who can actually guide the crew and do the work. That's it from my side. Thank you. Thank you all.
Thank you, Judd. Let's hear from George to conclude this round of presentations.
Good morning from myself. I'm George Kriezis, Technical Manager of Neptune Lines and Neptune Dry. We are owners and managers of 19 vessels, 14 car carriers and 5 bulk carriers. And we have inherited 5 ballast water treatment systems from new building, and we have made retrofits in 9 vessels. I have put the questions of the panel, and I'm trying to give you some feedback on these questions. Where do we stand with the ballast water management systems, and what is next on the regulatory agenda? I would say that installation of ballast treatment system is a mature business, and many ships and companies have already performed such installation jobs. And we also, in our company, have 5 or 6 years experience running the systems. The US Coast Guard has approved many systems, so there is no excuse for someone to say that we cannot find the system. Now, there are some new rules and regulations that EFI has clearly described better than myself. I would like to stress a little on the biological testing that will come soon, or is already required for some flags. And I think this is very important. We have been using a similar biological testing for the VGP for ships trading in the United States. And there are independent laboratories that come on board and take the samples. These have to be analyzed within a short time. I mean, this is a difficulty of this analysis. They have to do it very short time. So the facility should be near the port where the samples are taken. And of course, this biological testing for us is an improvement, because so far we're buying a system that was never tested before putting it in use. Now, if there is a problem, this will be identified in the beginning, and then we can fix it before we start using the system. It might cause 1 or 2 delays to the certification, but if we are planning it well, we might reduce this time. Now, some other issues that we have seen is that some port states still do not accept ballast water treatment systems to be used, and still require ballast water exchange. Ukraine is one of these countries that requires that we do ballast water exchange when we enter the Black Sea. Of course, this is creating a lot of problems to our operations departments, and they have to identify, if this country allows or not allows the ballast water treatment systems, and allocate time to perform the exchange in advance. IMO should take note of this. Another important submission that is coming for next MEPC 76 is from Liberia Intertanko and Intercargo, and this is for the operation of systems in ports with challenging water quality. This submission is a very good submission, as it solves one of the big issues with any systems in a very logical way. What does this guidance allow? In case of operation in a port with bad water quality, high turbidity, high level of suspended solids or low salinity, you can do ballasting in a bypass mode And then the ship moves outside of this area to far away where the ballast water exchange can be performed, and then you can do a treatment on a good quality water and have this on your vessel. So this submission, I think, should be supported by all the flag states. Is there a need for additional crew training? And what are the key operational challenges for installing a ballast water system? I'll start with crew training. Crew training is very important, and suppliers should provide video and CBD training for the system. And this should be used on board the vessel as a refresher also. Some suppliers offer training through the internet to seafarers at home. This has not proven very effective, as seafarers are not very diligent at home. Learning of the system through using it is also very important. And this is the reason that we operated all our systems from the new building immediately, so that crews got familiar with the systems and all problems were solved before the rules became mandatory. We have seen that systems not used are facing a lot of issues. Regarding the operational challenges, the most important is good planning and allowing sufficient time to prepare, and then implementing good project management. We have performed 9 retrofits on 5 sets of different vessels with different design arrangements in 2019 and 2020, all while installing tank scrappers. We used the same company for 3D scanning and developing the design. The technical department and myself personally were involved in close cooperation with the design office to finalize the design and make all the corrections. We use the information provided to make a detailed specification and get detailed quotations from the yards. Our superintendents were involved in the design and the generation of the specification, so it was easier for them to follow up during installation. Even our last installation in China, which was the most complicated on a bulk carrier, was done remotely, only with the attendance of the local major engineer. This was possible as the preparation work was done carefully and all contingencies checked in advance. What is the key feedback from the market for the ballast water treatment installations and operations so far? We have seen studies from ABS in 2019 and Martecma in 2020 with feedback from the market. The latest study, out of 950 systems, 16% were reported not working and 57 with problems. Most of the non-operating systems were from new buildings that installed the systems and companies decided not to operate them from the beginning. This was not good for the systems. Retrofitted systems appear to be performing better. Most of the problems were with control system software and then the filters. Some types of systems had more issues than others, so the maker selection is very, very important. Support from the suppliers is likely, as most of the effort at this time is made to deliver the systems timely. This should change after the peak of retrofits in 2022. So it is important to select systems available near the working area of the ship. If a ship is trading in Europe, there is no point to purchase a Far East system. It is important to select well-performing systems with large reference lists and the most common methods electrochlorination, full of side stream or UV. This covers 75% of the installed systems. We have been running our systems on 2 vessels since 2014 with minimal problems, and the rest since 2019. The longer-term performance is still unknown. Any lessons to be learned and best practices to be shared? Careful selection of the right system and size for the ship type and trade is very important. I'll give you an example. If you time charter your vessel, you should avoid selecting a chemical injection system where you have to buy the chemical instead of producing it by electricity. The charterer will not pay for the chemical. Early movers, we have seen, suffer the most, but also gain the experience and, the systems become standard for them. Proper installation and commissioning. This is very important. Dedicate resources. Select a good yard or workshop and allocate time for commissioning. Do not cut corners on this. Know your system design capabilities, as some of the other speakers said, and operate it within these capabilities. Regarding the filter, I believe that the usage of the filter is a must, despite the problems that we face sometimes with these filters in dirty waters. The filters keep the big organisms greater than 550 microns outside of the ballast water. And these bigger organisms are more resistant to UV and disinfectants, so they don't get exterminated. But another advantage of using a filter is that the filters keep the ballast tanks clean, less mud deposits, and this is very valuable for ships, especially bulk carriers over the years. Another solution that we saw that is very helpful, if there is a skid-mounted solution and there is a space to install it on board, please select this to minimize the installation cost. Simplicity is very important in the installation. One last item to consider is that the classification is a problem in the approval. We have seen that they are flooded with requests and need a lot of time to make the approvals. We need to put 3 months in account for the classification to finalize their approval. As the other persons also mentioned, the TRO sensors, which are used on sampling a liquid for analysis, are a bit prone for damages. And we have seen that they have been developed new sensors that can measure directly on the flow. And this potentially will simplify the systems in the future and reduce the installation costs. And as also some of the other speakers mentioned, contingency measures should be included in your revised ballast management plan. So this should be clearly specified so that they can assist the crew in case of any eventuality and any problem that we are facing. Thank you. This was part of my presentation.
Thank you very much, George, for the practical side that we wanted. Now, I would like to, I'm amazed by what both George and Jad commented on the bottleneck of the classification societies and the late preparation on behalf of the owners. As Jad correctly pointed out, these things, we say the same things over the last, let's say, 2 decades. So it's the same and the same thing, and all of us need to be prepared. Now, given the COVID situation, I would like to ask each and every one of you, from your perspective, what has been the COVID impact to your operations from your point of view? And are there any best practices that worked well during this unprecedented, let's say, pandemic? So we've seen travel has been restricted, a number of challenges for the installations, from the maker side, etc. I would like to hear from you, starting with Effie. Your thoughts. What happened with COVID? How has this affected you?
Yeah, I think 2020 will be the year of COVID and how it reflects the changes in everyday's life. So I remember last year that we were in GREEN4SEA, and that was actually my last conference that I took place back in February. And after that, everything changed. So we changed the way that we do business. So we do have all these virtual meetings from all the platforms that we have. All the companies would like to be in the digitalization. So in case you have this operational ramp up, you will be able to cope with this and be agile in these new circumstances. So from the operation, as it is in the office, we are definitely working like it was before. Of course, it is affected the first months or the first weeks in order to be normalized, how there will be the deliveries, how our service engineers will be on board. But after that, this was normalized as well. So I can say that it was affected, but not as affected by other business in the planet. In shipping, it was different.
Okay. Panos?
Thank you, Apostole. Of course, the meetings and so on is a common knowledge. It affected the promotion and so on, or maybe discussing some new items with customers. However, I have to say that we were fortunate because installations, for instance, or major points of service, we have deployed permanent personnel, let's say in China, in Singapore, in Turkey, in the Middle East. Therefore, we did not, I would dare to say that we did not have any issues regarding retrofits, no issues regarding service. The only issue that we had was the completion of our new certification for the new version. If COVID was not there, we would be there months ago. But we cannot bring scientists on board the ships to complete the shipboard testing. That's the main pain. The customers, which is the main question from you, I would say, how our services affect towards the customers, I would say was minimal because of the high level of deployment of permanent personnel of ours.
I would dare to say, from what I hear from both of you, that if COVID was not there, we should have invented it, let's say, to put in that sense. There was no impact in your business and everything worked smoothly.
From an environmental point of view, yes.
Dimitris, any thoughts from your end?
Yeah, actually, I think F and Panos have placed the landscape very well regarding COVID situation. From our perspective, yeah, the delay in MPC 75, yeah, drove us to have our system approved according to the code a bit later than anticipated. To the business, in the early stages, yes, we have seen a kind of confusion in the shipping industry, mainly driven from the difficulty of travel. These have been proved also with some of our customers that have delayed the attendance of the dry docks or they have pushed it back for a while. Now, internally, I would say the Nora is placed very well in all around the globe. So we have a variety of service engineers with different nationalities that were able to comply with local regulations. So we didn't have any issue on service and on service attendance and commissioning on board the vessels. We have people that they were remaining in Korea or in China during COVID situation. So yeah, we have not been affected significantly from that.
Okay. Let's hear from Jad. Jad, what have you seen with the COVID situation?
I see that looking at it from outside, I see that a large number of ship owners have actually pushed forward their retrofits. They have done so. They're receiving a lot of understanding from flags, from the Coast Guard, from everybody, and this is a fact. So things are delayed quite a lot. I don't know about a lot, but it's in the matter of months. You can get 3 months extension easily from any flag nowadays. We have seen a challenge when it comes to retrofit and sending people to do scanning and surveys on board the ships. It doesn't help if you have people in Houston and the ship is in Panama. You can't go to Panama. Even if it's a 30 minutes drive, if you're in Greece, you can't go to Turkey. It doesn't help. You cannot have people in every single city. Even in the US, we couldn't send people across the different states. So this has been a challenge. It's equally with the service and maintenance and upgrades, because a large number of ships are now upgrading their existing systems to USCG type approved ones. They're doing a large number had systems that were never operated when they were put on during new building that are now finally trying to revive them, and this needs a lot of work. It's a nightmare. Sending people around the globe like this has been a nightmare for the industry. But otherwise, in China, things are normal.
Yeah, if you are in China, yes. George, let's hear from you.
Okay, we performed 3 retrofits during the COVID, one in Bulgaria, one in Turkey, and the last one in China. The one in Bulgaria, we had our superintendent already there, so we were able to finish the job. We had to get the service engineer. We managed to get him on time. In Turkey, we went by land. The superintendent went by land, by car. He crossed the border and he went to Tsoulos for the retrofit. And in China, we could not send anybody. So in this case, we got a technician, a service engineer from the maker, and to be present during the whole installation process. And it was a lot of headache for us, but what we managed to do is make a very good preparation. So we prepared with our designer very well. We double checked that everything is working. We don't have any conflicts, that the pipes will not go there or will not fit. And with this, with good specification to the yard, the person of the maker attending, we were able to make the installation without any issues, which was amazing because we had a lot of headache for that. So it's creating a lot of headache for us, but we can manage.
Okay. Now, my next question is from your perspective again. What is your key concern for the next, let's say, 12 to 24 months? Your key challenge, let's say, that you have ahead of you. We heard from Panos. They introduced a new system without a filter. So we're going to go back to this later on. But from your perspective, starting with Effie, what's your key challenge ahead of you? I mean, within the next, other than the possible, let's say, bottleneck with the service that you have to provide to a number of ships, because as Jad correctly pointed out, we're going to be something like a huge workload ahead of us. Other than that, what sort of challenges you prioritize? Let's say couple of things, maybe key challenge. Effie, from your perspective.
I think the customer support is very important. The vessel all must have operable systems. So you have to be proactive and you have to provide the spare key and the spare part on time. So every vessel that has a ballast water treatment system must have a system that is working, because every time that is not working, it is discharging water that is not compatible with the convention itself. So the first thing is to have the customer support that is desirable. Second is to provide the training and to make sure that the training is sharing with the crew, not only during the commissioning, but you have all the tools of that before, and also, as Dimitris said and Panos, to have this training not only for the system itself, but also for the legislation in order to be prepared, to have your customer as partner, because the vessel must comply with the convention throughout the compliance without the scrapping period. So you must have a system that is working throughout these years. And this should be with the maintenance plan that you have in place, with a program that is very special to your customer. And you have to provide all these special tools that are effective and agile for the vessel itself and your customer.
Okay. Panos?
Thanks, Apostole.
The priority?
Yes, the priorities. First and foremost, spares, as Effie rightly said. We fortunately have spares for deployment in 3 different time zones. So US, Europe, and Singapore. So anything that happens, something can be sent at no time, despite the simplicity of our system, let's say. Otherwise, we have installation challenges, as Jade and everybody is reiterating. So more installations can be done, let's say, can be completed successfully in 90% of the, with 90%, let's say, success in being smooth. But owners must allow enough time for installation to be really completed, commissioned, tested, and the crew properly trained before vessel leaves the yard. Regarding crew training, it's not only the officers and the guys that are present during commissioning and handover, but also, I would say, the future crew on that vessel 6 months ahead. Mm-hmm. What we do at Ecochlor, we have continuous crew training because of this. During every chemical resupply that we do when this training is needed. So this is the only way forward, especially at these relatively early stages of crew familiarization worldwide.
Okay, Dimitris?
Thank you, Apostolos. I think, yeah, since I'm third in the row, F and Panos have managed to cover a lot of what of the challenges. I just wanted to emphasize to the fact that yes, as F said, we need the owners as a partners on this journey. We understand that the ballast water management system is nothing that actually creates values to their trading routes. We understand that is a headache, is another headache for the operations, but is a must. We need to anticipate on that. And the biggest challenge is to manage to pass this mentality to the crew that there's no way out. You must operate that system, and you must operate that compliant.
Okay. Jad?
I have basically one major concern, and that is, I already see it now. I'm afraid that the more press we put on the shipyards and the engineering and everything to put systems, and the quality of the work will be reduced. I already see crazy installations on ships, things that should never happen. Imaginations, people playing 3D like it's in Minecraft. It's not, it's a ship, it's equipment. We need to fix it, we need to work with it, we need to pull it apart. It's easy to look at it in 3D. In practice, it becomes different. I'm afraid we're going to see more and more of that. And so the remedy is to put people like Josh sent. He said he sent people to China from the maker. It's always good to have somebody there from your side. The second concern I have is crew training. We all talk about it. I don't see that happening properly nowadays. We attend a lot of retrofits in China. And it's always hurry up, and then deliver the equipment, and then we leave. And then we don't know how to, okay, you can press the buttons, but then start maintaining the system. And then we change the crew in 6 months. It's crazy.
Exactly.
It is not happening today as we want it to be. And we need to take care of it. Those are the two things I wanted to mention. Thank you.
Okay. And George?
Okay. Our biggest concerns are not related to ballast systems. It's more with the CO2 regulations. But in terms of ballast systems, I would say that we still have 4 installations to perform, 1 this year and 3 next year, to finish all our vessels. And regarding what Jad said about the installations, I believe personally that the technical departments of the companies installing the systems should pay attention in the installation, in the design, in the selection, where the pipes will pass, where we will install this, where we will install that, so that it is clear for them who are the operators of the ship. The design office doesn't have the experience of the operation on board, so they can say exactly where they should put it, where they should place it, if it is good, the location, if it is not good, and all that. So it's very important, the technical departments to get involved and not just give the design to a design office and say, oh, do it for me, and I will get it with the key ready to operate. It's not like this. We need to get involved. And regarding the training, I agree that it is very difficult. What we try to do is use one system for most of our installations so that the people get trained from one system, from one vessel to another vessel. So this has helped.
Yeah. We've seen that happening with the ECDIS in the past. I mean, we've seen people replacing full ECDISes, let's say, to put the same ECDIS across the fleet. But this cannot happen with the ballast water treatment systems unless you select the same system in advance. But we've seen that happening with ECDISes because it was not so expensive. Because people, as you correctly pointed out, especially with as they fitted ECDIS and they purchased ships, they found that their fleet, they had, let's say, 2 or 3 makers. And that created a mess from the crew. So we fully understand what you say. Now, I'd like to ask our makers we have in this panel, George, in his very practical, I would say, fine presentation, but very practical, which I really love, he pointed out 16% of the systems are not operable. 57% of the systems are having problems. You know better than anybody else because you have the systems, and you know that the system, you know if the owner, let's say, is training their people because they're going to come to you. They know if they're asking for spares, if they're asking for instructions, if they're asking a lot of things. And I'm sure that you know how many of these systems that you have already installed are operating and how many of these systems are having problems. What is your feedback with respect to these figures? I'm repeating the figures: 16% not working, 55%, 57% are having problems. Effie, because it's a huge number. If you add these numbers, it's a huge number.
It is a huge number, Apostole, but behind this number, you have to make a story. So there are some, the number is there because, and the story behind is that there are some vessels that have a system that is just installed and is not operated for 5 years. So after that, it starts operating. So is that number reflecting this, this system as well? So there are challenges in
that's why we're asking you. Because
yeah, okay. So if the studies are from ABS and from Artecma, and they had a questionnaire to a lot of vessels that, and the data, they were not reflecting as it's supposed to be, because we don't have a picture that the system is not working because you had a failure in TRO, because there was a reagent that expiration date was reached and it was not changed. This is not meaning that the system is not working. And the main question is the determination of not operability is after OMSM guidance and after crew followed the OMSM as described by the manufacturer.
You highlight the key problem of all these surveys and all the surveys in general. It depends on the quality of the data you have. Maybe
this is for sure.
Maybe we should have more transparency. Maybe we should have better collaboration between those who conduct the surveys and some more feedback in order to provide these, let's say, additional statistics which we don't have. Let's hear from the other two makers in the panel. Panos, your thoughts?
Thanks, Apostole. My thoughts, I would emphasize what Effie said is very accurate, but I would add what Dimitris said earlier, like the fit for purpose selection of the systems, because, well, if you don't choose it properly, maybe it will never work properly. As George said earlier, simplicity is vital for the installation, but also for the operation. Well, if it's not simple, you know, and maybe crew training is not perfect, or if it's not simple, actually it can never be have a smooth operation under certain operating conditions. So system complexity has been one of the most significant lessons, we believe, for the market, and that's why a lot of guys come to us as a second wave, I would say. Thank you.
We'll come to the second wave. I have a question later on.
Okay.
Dimitris, your thoughts?
Yeah, to add to what Effie and Panos have commented, and I'm sure Jad will agree, is that we have seen, we have experienced actually many issues right after the installation that were coming from the design. We have seen wrong pressure drop calculations resulting to not operable parts, that the makers are not fully, let's say, responsible on that. But of course, this comes also to the planning that, and for this reason, we were screaming from the early phases, please collaborate each other, the design company, the maker, the owner, start early and evaluate those risks and try to minimize that. In terms of equipment, all right, the majority of the equipment are marine approved industrial equipment. And from our case, at least, we have seen some failures in the electronics, meaning some PLC cards and here and there, not any significant issues. And the last thing that I would like to add is that is also the mentality of the people who operate the systems. That we have experienced same systems on the same vessels with the same owner, different person in charges of the fleet, different service requests. One vessel is operated fantastic. The other one, we are receiving service claims, simple service claims, but it's a matter of paying attention.
Again, I would like to suggest to Effie, who is sitting on the BEMA board, maybe BEMA should conduct a survey, because what we hear, if someone hears anyone, and that's ABS and Martecma, but someone who says, let's say, I'm coming forward with 950 feet installations, and I'm saying to you 70%, 70% are not operable, either because they're having problems or they're not operating at all, that's a huge problem. You know, that's defaming. That's a huge problem for the makers, for the market, for the industry, because systems are not reliable. This is the key message. If someone hears 70% of the installations are not working, that's a huge problem for BEMA, for the industry of the makers.
Actually, it's a huge problem for the environment itself, because we have to remember that every non-compliant discharge is D2 standards that is not compliant with the convention. So we all must join forces in order to make the systems operable. And what is operable? Operable is to have the crew follow the OMSM, to have a successful installation. And it is good now that we have the commissioning sampling, that any, for example, installation drawback, for example, a wrong valve that is missed on the ballast piping, or some arrangements in the deballasting line. This all be solved with the commissioning sampling, because the commissioning is not there to prove the efficacy of the system itself. It is there to prove that the system is installed as per the ballast water management plan.
Yeah, but again, the problem is, I asked, yes, Jad, I'm coming to you. The problem is that each one of the three of you have actually avoided to navigate away from providing a specific figure saying 2% of our systems are not operable, 0%, you know, and if you say 0%, that's not true. So I would like to ask you to be reasonable. I mean, for the sake of the industry, we've been recipients of negative publicity about the ballast water treatment systems over the course of the last 10 years. That correctly pointed out that at some point, yes, as a wise Nestor, to put in that sense, yes, we have a convention. Yes, we all have to work together in order to provide systems work together. All of us in the industry, not necessarily, because the makers are not the bad guys. But again, what is happening is a problem for the industry, for the makers, starting from the makers, but going to the owners who operate the ships. Jack, yes.
I just wanted, I think we have maybe one of the best makers. All three of them are very serious, but to put some other aspects on this issue, it's not always the operator and the ship. There is some problems sometimes with the equipment, and we see that. And it's important to look at that, acknowledge it, and work to fix it. In general, my general recommendation is look at the oily water separators. Anyone on any ship can operate them. They're simple. They use basic rules of gravity. Less components, more common components, less specialized equipment. That it works. You know, give a chief engineer any valve, they will dismantle it and put it together, and they can repair it, and the equipment will work all the time. If your equipment was only made of valves, it will never fail. And so let's look at both sides of the story here. I think it's important, and that was my point here.
Okay, Panos, yes.
Jade, you gave me something very interesting now. Regarding oil water separators, it's again a fit for purpose for today's operation issue, because as a matter of fact, if the crews are truthful, 7 out of 10 oil water separators do not work either at all or they do not work as they should. So the crew has to find, solutions. They are stuck with the problem because of the fit for purpose of the certified equipment for an operating condition many years ago with different chemicals in the builds. So again, fit for purpose comes to the ballast water treatment systems. Sorry, that's all.
Panos, that's food for thought for Martechma and ABS to conduct a survey, from what I understand. The oil, water.
And I have data for you for this. Irrelevant to our panel, but I have data.
Correct. So, Effie, yes.
Yes, but in all water separators, we have a visible discharge. And in the convention, we have this invasive species, the invisible invaders, actually. Yeah. And also in all water separators, we have the penalization of the vessels, of the discharge. In ballast water, we are not yet there, but we have to prepare ourselves and make sure that the systems are working and we fix everything and we have this evolution of the manufacturers, etc., because the penalization will be there in near future.
Yeah, George.
Going back to the ballast water systems and the surveys, the majority of the non-operating systems were for the new building systems, as I said. And, the yards were installing whatever was convenient for them. The Japanese yard was installing Japanese makers, the Korean, the Chinese makers. And they were not thinking, what is the best for this vessel. It was what was available to them and at a good price to install it in the new building and finish the story for their owners.
Yeah.
So these systems, will take time to get stable for the owners, to use them. The retrofitted systems, we don't see many problems. We don't have any real issues on our systems. Minor issues we have, but major issues we don't face.
Again, it's very clear what you say. It's the decision-making process, absolutely. Because on the retrofit, the manager selects the system. When it comes to new building, it's exactly what you said. You have what the yard is selecting, and otherwise you cannot, let's say, change it more or less. I would like to go back to the makers, and I would like to ask, Panos presented a new solution without a filter. We all understand the extremely benefits of using a system without a filter. I would like to ask Panos if you expect what you said, a second wave, a second generation, a new generation of systems to be in the market other than yours. I would like to also hear from Dimitris and Effie if they expect any sort of upgrades into better designs in the future. Panos.
Thank you. Okay, I unmuted myself. Regarding second wave, well, somebody would get to a second wave of system if could see that the problem, there was a problem, and for some vessel sizes and types there is an issue. That's why we went to the filterless, and only if somebody has the ability, the technology allows them, let's say, to go to that second wave. For instance, a UV can never be a filterless. It's impossible. So I would say a second wave of systems will be rather limited if somebody wants to be serious regarding the effectiveness. With chlorine dioxide, I believe I explained during the presentation how come we managed to do that in a serious and effective way for the future, let's say, operational excellence for our customers. So we give today lower capex, lower installation and maintenance cost, and fully reliable operations, eliminating the filters. Whoever can come with a reliable idea, by all means. But I think science cannot be invented after so many years of many engineers, getting.
You produced a system without a filter. You fooled yourselves, let's say, many years ago.
You will not believe the story. When we went initially for lab testing, we went without a filter, and they told us, "What are you doing here? Everybody has a filter. You're wrong. You must get a filter." So we got a filter. That's how the story started.
That's okay. I would like to hear from Effie and Dimitris. Filter may be one way. If there are any other ways that you expect to have this technology pushed forward and maybe provide some sort of, alternatives to the market.
Yeah, I would like to continue the story of Panos of not using a filter. And next to the land-based facility, I think it was back in 2010, we used actually a system without a filter, and we failed, actually. And we failed because we realized that in order to cope with the D2 standard, we had to go up to 30 to 40 milligrams per liter. And this was not acceptable by GESAMP. It was not acceptable with all the risk assessment that we did on toxicity. So if we had the possibility as a full flow electrolysis system to go without the filter, we would go for sure. So this is to continue the Panos story. And in ERMA first case and the product, we try to get data from the installations in order to make an evolution on the treatment itself. So we will have, in 2020, we ran a full process of type approval of a larger electrolytic cell that will introduce within 2021. To cover also a bigger capacities. So that was an evolution from our side, and we keep up whatever is happening to our majors and the components in order to integrate them in our system.
Okay, Dimitris? Yes.
Yeah.
Yes.
Regarding the comment on the filter, okay, I'm not an expert. I have not been involved in my previous experience.
I'm not saying you should comment on the filter. Any sort of other technological advances you see, and maybe provide some, alternatives to the market. This is my question. Panos, Ecochlor solved an equation without a filter. That's
I would say that here we in the Nora Apostolos, we have remained at the same design as we have started. We have upgraded our approvals, but only in terms of replacing or alternative system components to meet the technology. We are the sole owners of the electrolytic cell, so the technology belongs to us. We are fully responsible, and we're integrating our cells in the systems. We have the ability to offer options for self-cleaning cells as well, which I believe we are the only company in the market that can do that instead of doing periodically acid cleaning. I don't see, and we acknowledge, we are fully aware that our system is designed for larger capacities. It doesn't fit for small capacities. We are going up to more than 8,000 cubic meters per hour treatment rated capacity. We believe that fit for the market purposes, and we stay concentrated on serving the market based on that. Also, as also Jad have mentioned, we are not using TRO analyzers, we are using ORP analyzers that we have seen that it has proven to be a reliable solution comparable to TRO.
Okay, George, you'd like to comment?
Yes, the only item that is causing us expenses and difficulties is the TRO analyzer. And we have seen that there are now inline analyzers that are marketed by some companies. So I would like to see some improvement on this part, replacing the TRO analyzer with something that is more reliable, less maintenance.
Okay. Now, as we are out of time, I will have to ask you to let's say, wrap up your thoughts. I'll give you 30 seconds. What's your, let's say, wish list as we move forward? What you expect to pass as a message to the rest of the stakeholders, to the industry, and what you expect to see forward? But again, 30 seconds to wrap up your thoughts. Effie.
So I will be brief. I would like to say that the convention is already 17 years old, and we all remember ourselves being 17 years old And while looking forward to a bright future that was beyond high school and all the time terrified about entering this adult world. So it was definitely a very scary period, especially for our parents. So we all remember that. And the same is applicable to the convention itself. So all the stakeholders all these years were taught everything they are going to need to know in order to become responsible towards the convention. And I think as a conclusion, now it is time for action and implementation.
Thank you. Panos.
Thank you. I would say, gentlemen, ship owners, all continue choosing wisely the systems for your upcoming vessels, be it retrofits, be it new buildings. Maybe try and be a bit more, apply more pressure to the new building fellows, yards, because they all are your vessels. Whatever you fit today, you will need to operate it day in, day out at the ports. We are here to support in the best way. And last but not least, please give some time for the class societies and the fine engineering companies to do the business, the job in the best way for you. Thank you.
Dimitris.
Yeah. In turn, I would like to suggest that utilize experience, develop work groups internally and externally. There are very knowledgeable and competent people now in the market and makers. And utilize all this experience required to cope with the upcoming challenges regarding regulatory effects.
Okay, and Jad?
To change the subject on this issue, my wish and my call for all stakeholders is we need younger and smarter people to be engaged in ballast water management, marine engineers, water treatment students that are coming out of universities to come out with better ideas to improve our technologies, to improve how we are doing ballast water treatment on ships. We should all contribute to that. We use a lot of time in MOAT consulting to go to universities and talk about ballast water management. Everybody should do the same, because at some point we will get I always say my children are younger and they will be smarter than me, and then hopefully they will come up with better ideas, and maybe they will help the makers and the ship owners make better decisions later on. So that's I wanted to finish with that.
Thank you, Jad. And George?
Well, my last comment is that the ballast water treatment market is a mature market. There are systems reliable. We can select a reliable system, and we can make sure that we don't face any problems. And we can, we don't have to find the most extreme solution, but one of the standard systems can do the job very effectively for a long time.
Okay. I would like to thank you all for taking the time to join us. I would like to thank you for bringing your views to this discussion, to this very informative discussion, I would say. I would like to thank you all very much, thank our viewers, and trust to see you in one of our future events. Thank you very much.
Thank you.
Thank you, everyone.